Okay, just to recap from the last conversation or last topic, we were going through transformations topic, and especially we were looking at graphical views, SQL views, and also transformation flows in DataSphere. We got some examples and also some exercises to do. You can do those exercises. This one is already published, so you can take this one from the transformation flows and do those exercises. In today's session, we will be looking at a transformation topic, but in a different object called data flows. Data flow is not only meant for data transformation, it can also do the data integration, which means it can connect to the source system and then transfer the data from source system and do the transformations after. So at an initial stage, we just talked about data flow for the integration only, but we didn't do any transformations at the time. So we go now in this today's session, we will look at the transformations inside the data flows. Some graphical transformations. If there are no graphical transformation, then we will also look into applying a scripted-based transformation inside the data flow. So that's going to be today's topic. As we already knew that data flow is not going to get any further enhanced in the future. It is going to be replication flows plus transformation flows in the future. I don't see any reason for learning data flows at this time. However, we are just understanding how the transformations happen in data flows just to make a support enable. In case if there are already data flows in the system, then you can understand how they were built and etc. That is A. And the second reason that we're going to learn data flow is for the scripting part, which is not helpful in data flows, but it is going to be the same scripting area and same wizard, and everything is 99 or even 100% same in transformation flows. Since we don't have access to the transformation flows with PythonScript editor at this time, because I don't have access to the object store in this particular DataSphere system, we are using DataFlows PythonScript editor to simulate the learning of transformation flows using DataFlows. So that is the second reason we are learning data flows today. I'm just repeating, it is the number one reason for the existing production support or existing support of data flows for anybody who already implemented data flows to understand how they work. And then secondly, for learning Python script editor in transformation flows, which is not possible in the current system, the system that I have. So we are simulating the same exercises using DataFlows script editor. Okay, so with that introduction, so we will go and start creating some data flows in the system. It's pretty easy. Graphical view, same as graphical view. So we're going to start with creating a data flow. I'll access DataSphere. We don't have to do all the transformations. They are same again, like projection, filter, calculated column, aggregation, same. Whatever you've been seeing in graphical view transform, they are going to be same here as well. So we will just quickly go through those transformations first, and then we move to the scripted based transformation in data flows as the second part. That's going to take an hour approximately. So in the first half, we will be doing data flows in detail. And then in the second half, we will move on to analytic model development. So So we'll start with the data flow creation in the system. It's pretty slow. I'll hit refresh. Okay, it seems to be an issue today. It's not responding. Okay, it's coming, but it's very slow, so that's fine. Okay, I have the same space, data builder. We'll go to the data flows. Same, you can do it from here or here, just to the data flow. You can directly do the transformation from the source as we saw in the staging examples. You can do so to connect from the source and do the transformation, and you can also take some of the existing objects from ETL folders of DataSphere. So I'm going to take the financials, search for the financials. If you don't see, I do see it, drag it. For the simplicity of explaining, I'm directly taking the transformation from the repository, but data flows are intended for connecting to your source and get the data from there. So we are doing just, I can do it, but it's just for the sake of time, I'm doing it from local repository. So that's my source. And then you can see whatever the transformation that you've been looking at in the graphical view, you see almost very similar. So you can drag these operators into the canvas. For example, this is for join, union, and projection. So you wanted to take a projection node and then paste it here, drag to this canvas and then connect. And then in the projection, there is no separate node or operator for filter. You can do the filter in the projection. So you can see this is a projection. And then in the bottom, you can see the filters. So you can apply the filters using functions on columns. And also you can use input parameters. And of course, operators are always going to be there. So there's nothing really you wanted to go through it again. You can apply concatenation, date conversions, string function, and even currency conversions. Also, we will be doing currency conversions later, as in the second modeling topic covered. But yeah, you can do all the functions that are part of HANA in using this one. And then columns are the ones that you already have in your data set. Input parameters, yes, you can use input parameters as the filter expression here. And then operators are logical operators, arithmetic and logical operators that you can see. So nothing new in the filter expression for you to know. I can just simply put one filter on the date. So I can say functions. I'll create a, yeah, I don't have a calculated column. So I think I better create a calculated column first and then apply a filter on that. So there is no another node for creating a calculated column. You can just do another calculated column here and then say I'm going to calculate a year. It's going to be, I can put as a string, and then I will be using 2. Sure, what is the function for year? I will just go to the functions and then look for the year. Year is the function name, so it returns the year number. So it's going to be a number. So I'm going to put this as a number, or I can even convert it, but that's fine. We're just doing very simple thing. Mine is int 8 should be fine. And then just going to put the year of, we're not doing any big thing, just a year of thing, and then put the columns. The navigation, you can't click on that hyperlink. If you click on this hyperlink, you're going to go into this one. So always click on the gray area so that it comes into the window. So take the date, click on here, and it will come to your window. So validate it. Okay, year expected one of these data types, date, time, and but received as a string. So year is expecting the date parameter as the data type, not the integer. So if I just keep the date, but we don't want the date data type to be for year. So there must be, yeah, so year expected one of these data types. So inside, I thought my date column is a kind of a already converted date, but it doesn't seem to be. So what I can do, so I'm going to convert this to date of date, and then just put the required format, which is going to be YYMMDD. Okay, MMDD, and then just leave it and end it with brackets. So year is always going to be working on a column that is date formatted. So still year is invalid. Let me see what are the other problems. Date is okay, and then this date is it should be the bracket here, and then guess here. That should be okay. Okay, still the problem. I'm converting the date to YYMMDD, and then another bracket is required. Not sure why it gone out. So this is now no errors found, syntax good. Now I have this column, I can apply this filter right in the bottom. So I go back to the columns and then all the way come here. The integer, it's an integer, so I can put the filter on the integer. I can go to the columns and then use this column as the column value for filter, or search for it. So you have a search button. Okay, so this is not coming as the column. Just let me see. Okay, so the filter in general SQL, you can't apply a filter on a calculated column in general, right? That's how select statement work. You can apply a filter or where clause on the columns that you are reading from the data set, but you are unable to create a filter on the calculation that is part of your select statement. So projection is simply reading something, a simple select statement, and you can apply the where clause on the columns that are originally part of your data source, not a calculated column. So where it's a very simple filter is a where clause. It applies on the columns that are read from. So I'm going to put the switch to the columns and say date, bring in the date, and then apply date greater than maybe 2020 0101. So that should be okay, or you can use an input parameter. So we are just basically did one calculation and one filter. If you're doing another projection, and then you should be able to see the year there. For example, I can just simply, I'm not going to do anything, but I can just simply add the projection here, and then connect these two. We'll be able to apply in the projection filter, and there you go to columns and then look for the year. There you go. You can see the year because this is now a select statement that can have the previously build query select statement to apply the filter on there. So which is okay. I don't need really, I don't need this one. I'm going to remove it. Then what I can do now, you can also do the join and a union and aggregation, everything as we were doing in the past. So really, should we do it? I can just show a couple of examples to do the join and aggregation. That should be okay, because we have done some examples on this topic before, so we can ignore it. So I'm going to do a join. In order to get the join, I will have to get something profit center or something. So just drag on to this one. Uh, it doesn't propose, it just put it another data set, and then it's asking, oh, whether you wanted to use it as a source or target. So this is going to be my source. So I'm going to leave it. And then by default, it's going to be source. And then from here, if you put it as a target, the arrow will come like this. It's going to be inbound. So it's a source. Now I will pull the operator join and then use it here. So I will connect this to join, and also I will connect this other data set to this join. So now my join is being established. I can prepare the join criteria in the join. It's going to be a profit center to profit center. Just the navigation's little changed from graphical view to this one, but otherwise it's okay. So you have a profit center automatically identified to perform the join. So which is all okay. And then now you can perform an aggregation to get the data by profit center description or something, profit center name, so that your numbers will get aggregated accordingly. So just put the aggregation onto this one and then drag it. Yeah, here you got the columns. Remember, for doing an aggregation, we wanted to keep the value as in going to be change aggregation to sum, and then the group by columns. Really, all these columns, do you need to have them in as part of the group by? No, right? You wanted aggregated profit center, so you need to remove this one. In order to remove or add columns, you will need a projection. So I'm going to insert something in between. This is a difficult part. So inserting is always I would really get. I tried the better ways to insert in between. It's always giving me a challenge to insert in. Otherwise, I select it and then remove it and put it back. That's a bigger challenge. So I try to keep it in between these two nodes to insert this particular node in the data flow. I wasn't able to do. So whatever the ways I select, it's this projection is not going between aggregation to this one. That's a bigger challenge. So what I had to do, not sure whether it was taken care after. So what I had to do, I have to break this connection and then do another projection to apply a change, which is not a really good way to do. That's because if we created a data flow, and then we wanted to apply something in between doing this pipeline. When you're doing a pipeline, this is a pipeline, and you wanted to apply something very kind of a transformation or adding some filters in between. It's making me really nervous by not able to insert it into. See, this is coming as in this, but it's really not allowing me to put this one. So this has been a challenge all the time for me. So what I can do, I wouldn't be able to connect, just to delete it and then redo. They have to really fix this problem, but I don't think by looking at this whole thing, they're not going to do any improvements in this application. So that's another challenge that I've always faced with the data flows. So you wouldn't be able to insert the nodes in case you've missed in the first time. And then now you put it back to aggregation, and then here you control the behavior of the projection to remove. whatever you don't want, like select all, and then you keep just you're going to select most of the columns. And then I don't want to remove everything. I just wanted to keep value and profit center. Looking for the profit center, I would just keep profit center this one, and then rest of all can go. Okay, that's all good. Think that should be okay. And then aggregation, now we'll get those two only. And you can put the aggregation to change aggregation to sum. And then finally, you can put this data into a data target. Just go and drag the target table. You can put a template table first, and then after that, you can change it. So it's a template table, and you can change the template table name to data flow template for financial template. This is going to have only these two columns as we saw. And then finally, just deploy this table, create and deploy so that you will be able to use it in this data flow. So it's a simple data flow that we created. But yeah, as I said, it's a bit too much maintenance to if there is any change to be done. And I don't see. There is another way to do this. If you are familiar with this CSN, oh, sorry, not the script. Come on. Come on. It doesn't. Okay, so there is a CSN notation somewhere. You can find. No, they didn't give CSN also. So you wouldn't be able to make a JSON format notation adjustments to control this behavior. It has to be done graphical. Okay, so now I'm going to save it and then deploy, and then further you can go. So it's not really anything different from here. So I'm going to put this as data flow. It's very slow today. For transformations. Okay. ETL. And then I'm going to put this one in the save. I'll deploy it and do it. I think it's taking very slow, and then execution time is really big. So I'll just leave it. But yeah, you can deploy it and run and see how this transformation has been processed. Okay. Yeah, that's one example. And the second reason that we are here for data flows is for the scripting part. So you got here something like script. You can add a script to the data flows, for example, here. If you are unable to do any of those transformations through these operators, then you got a scripting editor. So click on the script and then get to the details. Now you get to coding language here. There's no option for you to choose a different coding language. They have restricted it. CP restricted it to have only Python. Then you can see the runtime 3.9. You can choose the latest one. It's just going to be latest one that is available here. I think we got 13, 14. Don't even know what is the runtime Python version currently available in. And then you can see the script associated here. So click on that window. So you get into the script. So you got the script window. This is right here. And then put this code in this block. You can also see some description rate saying incoming data frame. They wanted you to use the data frame, which is part of your NumPy module and pandas the Python modules. Can you import additional libraries? No, that's another challenge. So currently they have enabled it only for these two NP and pandas. I don't know why they have restricted. only to these two modules, we will have to really, I'll have to know. I don't know at this time. This is the same case even in transformation flow Python script as well, which is part of data lake. So that said, you will be doing some exercises using pandas library. Not sure whether you're really interested to go into the general data engineering or data science area. So if you are really looking at to get started with some basics, then you can do some learning. This will help in Databricks as well as general data science as a foundation. If you already know these modules and how to work on the data frames which are part of your Spark compute, then you can skip this. This is because this is going to be very basics. I'm trying to introduce I'm trying to introduce you to the simple exercise, not by not learning entire Python scripting, Python coding with all the variables. We can't do at this time, like declaration of the variables, what is tuple, what is an array, what is a dictionary object, what is list. These terminologies will go as part of standard programming practice. But the way things changed with GPTs and generative AI technologies, you can easily find and get your understanding clear when you do the exercises in the system. So I would really say if you know one programming language like ABAP or any other JavaScript or any other that you knew before, then it will be very similar to that, and you just directly go and do some exercises and then ask the GPT to get you some help whenever it is needed. So instead of learning entire Python scripting programming, which is not necessary in this generation of in this era of generative AI, let's take a look at it. How that is, we're going to take few steps to get familiar with initial initial learning on this one. But if there are two cases. If you're already new Python scripting using Spark data frames and other areas, you can skip this one. You can simply drop or actually come back after an hour or so. This is not going to really make you any use for you because you already done the Python scripting program. And second, and you wanted to always be in the SQL and don't want to get into data science or data program, better handling of programming, data processing in different modules, then you can also skip. This is not really going to mean anything for you. And then third use case, you wanted to be good in SQL and wanted to leverage Python for certain activities related to Spark, then yes, please be here because this is a bridge there is a bridge PySpark. I don't know whether you heard of you know about PySpark. PySpark is basically a Python module or library where you can implement your SQL in a Python interface, in a Python runtime. Basically, you're going to write SQL in a Python interface so that you can interact with Spark data frame or processing large amounts of data using SQL coding, but in Python environment. So if for that use case, yes, you can be there. So the previous use cases where you already knew or you don't want, then you can skip this one. Okay. So with that introduction, let's move to the basics that are what I generally prefer to do. I took a Python course separately outside in general YouTube session, which is longer, and I really meant that it's not required. So if you are coming from SQL background and also BAP and BI background, we directly move on to an environment where we can directly practice. So the environment that we can generally do for data science or Python, it's simple to configure. Is you can have REPL, that's one thing. Or if you are going to extend this your learning to data science, then or AI, that's going to be Google Colab. So Google Colab is a Google Collaboratory and a science lab. If you haven't used before, I would say just go and set up your, it's part of your Google Apps, your Google account. So just like your Gmail, you will be able to access Google Colab. You will be able to access Google AI Studio in Notebook LLM. There are a lot of AI related applications that are going to be part of your Google account, and they make you a lot of work easy. So you can put your notebooks, you can create a notebook. This is a easy way. You can write a program or you can create a notebook in Databricks or any other data platform interfaces. Notebook is a common way of writing script so that developers can easily maintain it and also run them in a sequential order and also write some proper notes, or what you call is a in coding language you put it as a, what is that, I don't remember the terminology, but just you're giving more explanation to the code, what comments or whatever you call it as. So you give them and you give the instructions on how to use your snippets of code and programs, functions, and everything. You can better organize using Notebook. So you can create a notebook using Jupyter Lab. You can use it in any interface. I can use a Microsoft Visual Studio Code, like a simple Visual Studio Code editor. And then Jupyter notebooks are already installed. This is basically you need a notebook runtime environment with Python. These two things together. You can use any platform. You can use Visual Studio Code Editor, Ripple. You can use PyCharm if you're comfortable with more with Python all the time. Any IDE, any integration editor you can use if you wanted to do your local install. Right, local install means in your personal computer. If you are not interested in installing Python or notebooks and everything on your personal computer, then that's when you use one of the cloud tools like Colab. They're going to install the runtime environment for you. They're going to install the notebooks, Jupyter notebooks for you on cloud, and then you can directly just access it. So let's go and welcome to Colab. So this is going to be, so this is for data science and mission. Basically, the intention of Google Colab is for data science and machine learning, but we are going to use it for our simple learning of Python programming. So because we are just going to use the code snippets. So we not at all any of these not in this interested in GPUs and data science or Gemini, how it works and everything. But we will be interested in doing several pandas data frame examples. Okay. How many you're going to do, that's all up to you. But there are a lot of examples. So you can say, this is for, yeah, there are a lot of examples. We will go at least few. So yeah, so how many you're going to do, it's all up to you. So we got code snippets from Colab to process your data using data frames language. We'll come to those ones, but I'm saying that it's going to be very helpful to get use a lot of examples to practice. That's one thing. We are going to use free plan for Germany. No pro plan is required. So it's just going to be okay. And then you'll, we don't need any APIs or anything in advance for AI Studio. We're not really going into those, any of those such thing. Okay, so but this is if you're expanding your journey in the data science and AI Studio, Colab is one of the nice and greatest tools that you can leverage for. So okay, with that, now what we don't need to do any of these things. We will directly jump to open a simple a notebook. So you can create a notebook from file, a new notebook in Drive. So, or you can upload a notebook from my Drive also. So I'm going to switch to my another Google account so that I can have the notebooks that I've already created before. So I can use this one, any of these notebooks, they are saved in my Drive, or you can create a brand new notebook. As we saw in the previous, you can say file and say no, new notebook in the Drive. You can do so, or you can open a new notebook from untitled. So you're going to say the same thing. Notebook has been moved to trash and returned to color. That's fine. So that's the previous one. So I think these were created and just left like that. So really, I want to create a new one. So let's create a new one. So choose your Google Drive folder if you wanted to organize them, and say new notebook. It's going to take you an environment where you can use it. So first thing that you're going to do, a connect. So you need a runtime. So you will connect to a host runtime. Google is going to provide you a default runtime for you, just so that you don't have to do any installation of. So it says Python 3, Google Compute Engine, backend, RAM, and then disk is already given to you. So you got a platform to say. So it's already equipped. That's it. So you don't need to do any. If you were to do everything here, then you'll have to install Python, your runtime, you'll have to install notebooks, Jupyter notebooks, write add-ins from the extensions. You'll have to do everything, which you don't have to do, right? That's what you're going to do. And then come here in this notebook page, you will see code and text. Text is for your documentation, and code is for your Python or Scala or SQL or whatever the language that you're going to apply. So now we'll start with text, saying that this is going to be a text. So by default, it generated with the AI. So I'm going to remove it. So now it's a text one. So in the text, you're going to write whatever the way. So this is my first program. And then you can do an indentation, insert images. This is all going to be for document, and you insert the hyperlinks, everything that you can, just looking good for understanding purpose. You will see a lot of notebooks with proper explanation. This is a markdown language. Even you see it in GitHub or everything. So you can adjust this as soon as you finish your thing. This is going to look like this. This is not going to get compiled. Whatever you put it in text is not get compiled. But whatever you're going to put it in code is going to get compiled. So now I'm going to insert another cell saying code. So now it's code. So whatever you're going to put it is going to go to the compiler. Let's say you want to say 3 plus 2, and then run this cell. It's going to give an output, which means it's executing in a programming interface. For example, if you wanted to do this one same in a Python idle, Python client that is installed on my machine idle, which will be doing the same thing, which is an interface where and you can also create a Python file and then do the same thing, 3 plus 2, and then it gets you results, right? So similarly, you can declare variables. Notebook is going to help you to do everything. And if you are going to open a new file, kind of new text file, and then give an extension for that file saying that plain text, what type of file you want to do. I would say Python file. So use the Python extension. This is for this file, and then say what you can do is just do A is 2 and then B is 3, and then just print A plus B, or just put C is A plus B, simple language, and then just print it. Print C, right? This is a simple program that you wanted to run, and just run it. And it's going to ask you first to save somewhere. I'm going to put, okay, that's fine. You have to do all these things if you are doing it on your personal machine. So it's a Python file. Now I can run it. So it's going to ask you to choose a runtime environment for this one. And then as soon as you selected the runtime environment, Python 313 is my runtime environment, it gives me results 3. So basically, you are able to code your Python program in the local machine. And same thing you're doing in a notebook as well, with a lot of simplicity. Okay. So now, now our exercises are going to be more in this area where we will be adding a lot of cells and then run them and then understand. So actually you don't have to do all these exercises now because you got generative AI. That's what we are really start coding with, or generate with AI. So what it is going to do, okay, you just tell something, say generate with AI, and you got, so what you wanted. I wanted to create a list of three what is that, cities in US, and then print them, something like this. So what it is going to it's going to generate a code for you, and then you can use that code, and then you will and then it also explain what is it is going to do. So yeah, you can see certainly it is the code to create a list of three cities in a and print. So where do I see it? So this is the one. So it's giving pretty much and then print cities, something like, it's a basic simple example, and then just say and then you get it printed. Okay, so if you say accept and run, it is going to accept it and run. If you say cancel and regenerate something else, you will be able to regenerate. And you can also do explain code by selecting it, and then say something should be available. Where is my Gemini? Yeah, I'll come to that. Explain should be, yeah, explain code. So it's explaining what is actually you're doing, whether you're using a dictionary or a list. It's a dictionary. If you wanted to do it as a list, and it will say the code first creates list and initialized with the string values, and then the print line displays this entire. So this makes so much easier for you to understand. And so that's what I'm saying. You don't need a training for any programming in this era of generative AI, because it's going to propose it for you, explain it for you. And if you make any mistake, it is going to propose another code for you to correct that mistakes also. But anyway, it's saying Gemini can make mistakes, but double check. But most likely it is going to work better than what we think, because it's trained with a lot of so anyway, so let's do the exercises that we have planned for this today's session. So I'm going to delete this cell, and then we're going to start doing the cell. So I have prepared one, and I also downloaded, you can download these ones. Where I put these ones are in the sessions. Okay, I'm going to add them to the folder today. It will be in the sample data, I guess. So this is going to the data set I'm going to use. And then this is the exercises notebook, Jupyter source notebook. So actually you can open this one. It's an on-premise, right? You can also import it into Google Colab as well, so that you get it. So first I'm importing into the Visual Studio Code Editor, so that I get a notebook that I already prepared for you. So you're just getting to your environment. Similarly, you can also get that notebook, upload it into your Google upload notebook. You're going to upload it from personal machine, right? So browse. Then you go to the folder where I mean you can download the file that I've given. So I mean download means you just put it in your local drive and then upload just the way from file import from your Google Drive, so that you can access that. Or you can even open that. See, I opened it in my local machine. So let me just delete it. So now you can see I've got the first markdown cell as basics, and I put same thing that we just talked about, and then print C. So this is Python. You can choose your runtime environment in the cell. in the Visual Studio Code editor. By default, it was because my file is Python notebook, it selected as Python. Even in Google Colab, I'm changing this quickly from one to the other. So I'm going to cancel it. I don't want to insert it. So you can choose your runtime, whether you wanted to do Python or a different programming. So let me see where I have the runtime setup code. Change runtime type, which is okay. Now you can, if you're really using runtime type, for our example, CPU is okay, or even you can use GPU for larger data science model processing. But I don't need a GPU for processing my sample data. So I'm going to use a CPU as the hardware. You can choose R and this Julia language. So one of these, some Databricks notebooks have more SQL and as well as other languages runtimes as well. So notebook is not restricted to Python. It can have any of the languages in that notebook. So by default, it is Python. So I'm going to use the Python. Runtime version, latest as recommended. Or if you wanted to go previous one, you can also choose to have previous one. So something like that. So you choose your settings from the open settings and then start doing your exercises here. So all my exercises are here. So I'm going to go through one of these exercises. You also can open this thing from Colab and do it. So I'm going to say, this is a basic syntax for listing. So even you can just take this one and try to run it. Put it here. I'm going to add another code. And then you are displaying the first row because the 0 is going to consider as the first row, and then just say list. So 1, 2, 3 is your the first row. The second row is going to be V1, V2, V3. So that code you can say, if you wanted, you change it to 1 and then run it, same thing, it's going to display this one. So your row identification is by 0, 1, 2, 3. Okay, that's simple syntax. So I'm going to add another cell and then take another example saying that this time I'm going to have a dictionary. The difference between list and a dictionary, you just find out the purpose is different. Just you can find for various scenarios in programming language. That's going to go into your programming language. So you can see dictionary is your variable of type dictionary, and then you are displaying column 2. Column 2 is you're going to be USA. So that's going to be, so you can identify any of the columns and list. If you have more rows, it's going to display all the rows here. So let's do it with multiple keys and values. This is kind of another example. Okay. So, and then just run it, and then you get here I have column 1 colon, and the list of the values for column 1 are 3. So which means you got 3 rows. In column 2, I got 3 rows, and column 3, you got 3 rows, 1, 2, 3. So the way you are displaying this data structure in like this, which doesn't look good, right? So you have 3 values, 3 values, 3 values. In order to put in a tabular format, you're going to need another set of coding lines, which is really complex. Not a complex, but a lot of tedious job. Most of the time, as a data modeling person, we will be using data table structures. So we're going to use data frame. That's actually more module provided in Python. Data frame is not only for Python. You can use Spark without using Python and then run the data frame. Let's do that with Python now. Data frame. And then how does it look like? So for that, you're going to need another cell. So you're going to need import. So anything that you wanted to import a library, an external library like pandas. Pandas is a Python library that you wanted to, you will have to import it first in order to use it. It's like npm. If you're using Node.js, if you're comfortable with Node.js, you do an npm install, right? Something very similar to npm install. Here you are doing an import. If you're doing an on-premise local machine, then you do a pip install and then you do the import. Import basically leveraging your module to be used in that program. So you can see that it's proposing a very standard code generated. So you can actually say tab, it's going to get you that one and start using it. Or you can even do your code. It says import pandas, that's our standard library, as PD, that's an alias name. And data frame, df is a variable, it's not a data frame, just a variable. But what you are calling a method is pd.dataframe. Data frame is a method in the class of uh, in the class. Sorry, data frame is a class, and the data structure is the method that is inside the class. So basically, it's proposing to read this library and run the module to get the data structure read. So for that, what we're going to do now, instead of doing this whole thing like this, now what we are really doing, we are sending this to a data frame, this particular variable. Since it was already declared, it understood that variable. Now, if you pass this data structure where a dictionary variable to this data frame method of pandas library, what it is going to do, let's try when you display it. Let's try this. Now you get a data frame, a tabular format structured properly instead of displaying like this. This is now it looks better, not only for displaying, but also for processing this data. So how did this was possible by using data frame? So you will keep hearing data frame a lot in every machine learning or every Spark compute and Python pandas. Everywhere you see data frame, data frame. Data frame is just it's like a tabular structure that that is prepared in Spark for processing dimensional structured data set with rows and columns. And before it was a structure, but not as a tabular structure. You can even build the tabular structure by using regular Python program, but which is unnecessary, totally unnecessary. Why does someone go and write everything on their own if when somebody already built a module called data frame and readily available to install and use it? So we don't want to rebuild everything what data frame has got in pandas library, right? So you're just going to use those libraries and then start working. So that's why, so understanding libraries, especially pandas, if you go and check the pandas documentation, you got this library with a lot of methods. This library has got a lot of methods. How many are required? It's open source anyway. Python is open source and pandas is also an open source. So yeah, you can install. We already installed and then get started. User guide. You got a lot of modules for doing certain different activities. If you can get exercises or examples from standard pandas documentation, or you can also get it from Google Colab to understand creating a list, drop duplicates. So if you wanted to draw duplicates, so it is going to be a import. Let's take a notebook itself instead of looking at it in a small window, the example notebook that what they have prepared. So this is a table of contents. You can see these are the notebooks prepared by Google for you to understand better. So this one is also I will download if you don't I will be download, or I will give the access to you so that you will be able to put it in. I am going to put it in the exercises, so you can access. So you can run them. So for example, if you wanted to see that there are first name has 4, and then last name has got 4 records, and then now you wanted to see duplicate rows. Just run this one. It says location identify and then index duplicated, so it's going to just run it. So it only displayed 3 rows, saying that why did it remove one of the see that, because it's a duplication, the same last name, 2 last names, and then also this particular see this particular first name also got removed because it has the same last name. We removed rows based on last name. As long as last name is same, it understood that it is a duplication, and then it removed the duplication. That's so there are so many exercises that you can think of to perform transformations using data frames. Okay, it's a quick practice for you. Okay, now let's do whatever we have planned to do. So this is one example that we can see, and then I'm going to add another cell. This time we will be, I mean, it's going to be super simple with all these AI tools. You ask Gemini, so then it's going to propose the code for you. So how do you ask chat assistant? So click on generate AI. So it's going to tell you an AI assistant, put it bigger, and then it always going to be Gemini on your right side, and then ask whatever, and you do something wrong. Let's say instead of like this, you put this code, and then try to do the df1, which is not a declared variable. Excuse me, and then run it. It's going to say error, right? So df1 is not defined. So then you wanted to understand how to fix this explain error, right? So now you can say explain error. It's going to come to the Gemini. Excuse me. And then it works, and then tell that this is your problem. And then it's going to suggest a fix, saying that use instead of df, display df1. That's the problem. Then you try to do it. So it's proposing, saying that don't use df1, use df. So you just say accept the proposal, and then it corrected automatically, and then run it. It's going to work. So that's how this Gemini is going to help with especially 3 LLM from Google. It's going to be super helpful. So anyway, so that's how you fix your issues, and then you take this example code and put it into your data flow transformation. Let's do that. Let's take an example. Oh, yeah, from here. Oh, you can run these ones, no problem, because I already installed Python here, right? For example, you wanted to do the same thing using pandas here and everything, run it. So it's going to ask me to choose the Python runtime. I have already 3.13.2 on my personal computer. It's going to run. Oh, this generate here is actually a Microsoft Visual Studio Code Editor. So yeah, you can see here, it's not able to understand a data structure. So, sorry, import. So in my Python, I haven't imported pandas. So that's why it's complaining. So in order to do the pandas, so you need to pip install pandas. So it's going to install, which you don't need to do because you're working on a version that is already available for you. So it's complain if you're working on your local machine, this has got your problem. So it's going to take some time to install the library, and that's when you will be able to use the import parameter. Yeah, it's done. Looks like now I will run it. Okay, so I think I may need another restart because it's just refresh, but it's fine. You're not going to do anyway. A new you're not going to need anyway this one because it's already there for you. So that's fine. I'm not going to run it in here. Just run here examples. So I will say collapse this. Take a next example. So here I'm going to say basics for data. I'm going to do and apply a transformation saying that I'm going to apply a filter on the revenue column where 200 is the value. Just going to do that and then apply this code. I'm going to add another cell. I can go through this code. Basically, you are doing two libraries here. One is NumPy, and actually NumPy is not required. I'm not using any of the calculation related to NumPy module. Now you put everything into this data variable for customer and revenue columns, two columns. And then in those two columns, I'm going to say add it to the data frame through the data frame module. Now, if you at this time, if you display data frame, it's going to display these two columns with 5 rows, right? And now you're going to apply a filter on that data frame data set where revenue is greater than 200. So it's going to display only these two records. And now apply that filter of data frame to another variable so that I'm going to display that variable. You can say display of final DF or just leave the final DF, both should work fine. So now you can see 3 of them displayed where revenue is greater than 200. So you can apply a column filter. You can also say display something like that to make it consistent. That should be okay. But if you try to apply DF, which is not final DF, what you can expect? You will be seeing 5 rows because the filter is applied at this variable, which is in the filter variable of data frame. Okay, so now everything what you're going to do to the data frame, because you already said data frame, or what are the possible things that you can do inside the data frame? Like we did filter, right? Data frame just now. Similarly, you can apply a lot more actions on the data frame. Not only just arithmetic operation to filter data on this column, but you can do a lot more in using data frame method. Okay. You will find those examples with the exercises that you have it in Google Colab. Now, another example that you can see, another filter example here, you are applying on the equal to, not greater than. Just pretty simple. You don't have to really do a lot here. Just a simple exercise. Another cell. I'm not going to spend any time here. It just to show equal to is 2 equal to, that's the syntax. If you try to put 1 equal to, it's going to complain. You can ask Gemini to fix the problem. You will be getting it. So everything is going to display only London because we applied a filter on a particular column value, which is equal to London in the city. The entire row is filtered. And then the rest of the other rows are out because the filter is applied on the data frame data set. Okay, that's the one. And then you can do some examples from Google Colab by reading the file path. So basically you may end up reading a file path, right? So you're going to read a file path as well. So in order to put a file, you can use the standard sample data from Google Colab. These are the sample data sets that Google Colab uses, or even you can import your own data set. So I'm going to import my own data set, which is fact transaction. That's actually in the sample data. So I'm going to put the sales transaction CSV. So files are saved elsewhere. This runtime files will be deleted when you shut, when this runtime is, excuse me, when this runtime is stopped, which is after you finishing work. So you'll have to do it again. So say this is not guaranteed. You'll have to really keep it. These files are guaranteed for you. Because it's your own data set. It will be removed. So make sure you have this data. So what I'm going to upload this CSV file into the data frame this time. I'm not declaring the values directly, since this use case is now to read the values from a CSV file. And in the next exercise, we're going to read the data from a table, a database table in DataScript. That's how we plan to do our exercises. We'll do the code, and then in this code, so we're going to read this one, right? So the Python has readily available modules that you can read the data from using read underscore CSV. So pandas giving this method for you. So use this method. So I'm going to give this method for you. If you don't know, actually it's pretty simple. Let's try it. So say import pandas as PD, which is okay. That's good. And then the next line, what we're going to do, we have to give the file path somewhere, right? So we need to know where is the file location. So file location is a variable. And then how do you know the file location? You can go here, copy path. So it's going to get you the path of the file. So this is going to be your file path. And then now your file location has the file, and Google already understood what you're going to do. And then it's proposing just simply and trust tab. So you see that it's proposed a code which is already what you are expecting to do. You're saying df, which is PD by pandas, and then read CSV. File location is your file. Even it understood the variable that you declared. It's not giving a simple general code. It's giving you a code that you can use it. And then you just write header of the file and just try to read it. So it's going to display the head is, I think, top 4 or 5. I think that's what it really meant. And then you can display the entire without worrying about head. Just display entire df. So it's just going to be df. Run it. Oops, just df. You don't have to call any other functions. So df, yeah, you got around 108,000 records with 9 columns. So pretty much you didn't do anything. You just given a location variable, and it understood and proposed the code for you. So this is another example. And then you can apply transformations on these file data set as in the next step. You can say df filter, and then do df. And then as soon as you understood that you're going to do a filter for this one, then you do certain, like on this any of the columns, to apply a filter, which we wanted to do, or we wanted to not to do, or it's totally. Let me get to the file that I already have here, instead of showing a different file. Just going to get to the right folder. So I'm going to, this is my exercise notebook on Google Colab, so you can see it. I think this is what we are really exercises, and this is the one that we are practicing. I'm going to use it, and this is a Google examples. So this is the sample data set, but we are uploading this one. And now after uploading it, now you can say filter on the store ID to this one. It's going to apply the filter on that particular thing. And then you can do an aggregation group by product. So you can take this code and then do an aggregation. come to this file, and then just do, now you read and everything is in df, right? So now you are really doing group by, df group by, into a variable, say group by, and then display that group by, and it's going to show revenue by product ID. So let's do it. These are the aggregation functionality that you have done using graphical. You can achieve this with your SQL also. But the example that we are showing, you can, most of them are done by SQL also. We are just doing. So that's all good. Now I move on to another example. Group, yeah, you can add this group by functionality with more columns as well. That's fine. Aggregation. Created a calculated column. This is how you create a calculated column. As soon as you put a new column that is not part of your data frame, and then it's going to create a new column. If you put something already part of your column, that's going to override that particular column. So let's do this one. Copy it and then come here. I will just remove it, and then instead of group by, I'm going to say net profit, and then remove this one, display, run it. So it's going to calculate revenue minus discount and minus cost to get the net profit. So you will be seeing net profit at the end of the data set. This is going to be your calculated column, which is not there before. So that's how we calculate it. So you can have a calculated columns, you can have aggregations, you can have joins, you can have a lot of functionalities in the data frame using data frame class, which is part of your pandas library, and even more that are relevant for your data science. As I said, you can find those ones from these ones, those examples. Yeah, timestamp, data indexing, containing dictionary, a lot of examples you can find it. Okay, now let's go to the final one. You can also use lambda function. So this is an example for lambda function. And you can use function in Python. So this is a def syntax, calling a function, and then put that function as a reusable code, right? Def is a syntax for creating a function. And SAP examples, yeah. So once you have the data in the transformation, now your data by default, it's like internal. Let me jump to the transformation. So you see something called data, right? So this part we are doing it for SAP now. So you got data here. Data by default, it takes whatever in the source. So the connectivity for this particular script has got 3 columns, and then this is going to get you those 3 columns. And what you are going to return is going to has to match to the columns that what you're going to as an output. It's like source package, result package in your BW transformation. So I'm going to have a data that's taken from source, and then I'm going to process that by applying filters, some aggregations, some lambda functions, whatever that I can do with data frame, part of NumPy, because NumPy is allowed here. Sorry, pandas is allowed here. And then send the final output to the columns. And that's when your transformation becomes working as usual. Okay, so I'm going to do that quickly. We'll create a new transformation flow, data flow. So I think I'll finish this exercise in 10 minutes and we can take a look at the questions. So data flow, new one. So you will be doing the same exercise or similar exercise in transformation flow as well in the object store of data lake of DataSphere. So it's just good. This time I will go get the same financials data, ETL. We'll get the, and then I don't need all the columns. So I want to remove certain columns. So I'll apply a projection. So for that, I just do a projection. And then keep only a handful of columns, which is going to be, I'll select all, but I will keep account ID and then a date, a value. I think that should be okay for my activity. So that I wanted to keep it simple. Okay. Think that's it. I will just delete rest of the things. Okay, 3 columns I have now, and then I will be attaching this to a scripted. So I wanted to apply a script here. So if I don't know what transformations I can do here, I will be applying a script. So in this script, as I said, by default, it takes the values from projection. And then I can put a template as the target as a result of the script. So inside the script, you can say details, go here and choose the Python script and then say edit, and then come back here. You have the by default columns that what you have there. And if you are going to add more columns as part of the script, then you will have to add that as well. Right? Or you can also add column from here, or you can directly create a new column also here if you're creating it from this one. So let me try to do the code. So you can remove everything what you have there, or just type in this. It's all just a commented code. That's fine. So what I will be doing now, data is your data frame. It's already taken care. Your data is already a data frame. So you have everything in the data. You can further change the data frame. You don't have to define a data frame of pandas because it's already taken care by SAP. Like they prepare a start routine. They take care of what is to be input parameter and what is to be how that data gets into that parameter in advance, all in advance. You go and write a routine to modify the data in that particular place by accessing already prepared connectivity as part of your graphical layout provided by SAP. So that's what here happening. Data is already taking care, this one, and then we're going to process that using some transformation. I have the transformations already example. So now we're going to do, okay, so we have a different column. That's going to be here. I have a different data set I have here. So we're going to apply that. That's fine. So I'm going to say, come back to the data sphere and then put the syntax. Data frame is a variable, which is reading the data. Okay. Data, which is also a data frame. Full about it. It's already data frame. I didn't explicitly import pandas or anything. SAP has taken care already of those. Okay, so data is already a data frame, and I'm saying in that data frame, I'm going to list the columns from source. I can choose all the columns or I can choose some of the columns. So I'm going to choose all the columns. Say account ID, that's my first column, and date, that's my second column, and then value is my third column. So I have 3 columns. I'm putting in 3 columns. Now I can apply a filter on one of the columns saying value. Like on the value, I can apply a filter. I can say 1000 as the filter value. I'm going to call this as a filter. It's not going to be a new column, right? I'm going to put it in the value column itself. So I wouldn't, I'm going to apply this filter, a variable on the, where is, on which column? Sorry. This is the new column, which is a calculated column. Wherever you see, this is a margin is not something that's part of there. So basically, I wanted to apply a filter on the data frame itself. So which is going to be, I'm going to leave this and then say df itself. Actually, I don't need anything because it's already df. So I'm going to apply a filter on value, right? All good. Anything else? Basically, I am applying a filter on the value column, which is greater than 1000. And then I'm returning df, which is your parameter final. But SAP already proposing to use return data. Does it really matter? No, because even though it is data, I already transformed data to df. So df is the final one. As long as I have df, that should be okay. So I don't have data need to keep, or I can keep the data as it is and without worrying about it. So this is all good. Now it's just applying a filter here saying everything good. So details, the bad part of this one is there is no syntax check. I don't know whether this is a good one or bad one until I run the data frame. So I'm going to say, so that's the ugliest part actually. See, local table, data frame, Python. So all good. Now we will save it. Okay, target table is not created. And okay, I will deploy this first, and then I will put this df as Python script. Okay, save it. Okay, data flow saved successfully. And then this is not deployed, so I'm going to deploy this one first. Think this one, create and deploy, create and deploy. The table has to be there inside. Okay, and you can do further transformations in the next example that I say deploy it and run it. Okay, what is the problem with operator script? I don't know. Let me deploy it again. Upgrading to as a maintenance for will end in October. That's fine. Yeah, I will move it to 3. Yes. That's not a problem. Just a safe side. And then run it. So until I run this one, I don't know what errors I would have in the script editor of Python. It's pretty bad. Now I will go to the monitor. That's fine. Discard it. That's a version change only, runtime version change. So it's running. Refresh. It's a very slow. That's the reason we cannot, because currently HANA is not having Spark runtime, right? And even in the future, we don't know. With that, this entire processing engine has to be taken to a different cluster where the Spark is there, and then process it and send the result back to the HANA. That's why even whenever you use Python script in DataFlow, it's going to be super, super slow, even for small records like 100,000. Currently, we do have 100,000 records, but still very slow just because it's going to take to a different runtime environment and then process it and then get it back here. So it's running for a while. That means it's doing something. Guess so. So it's not recommended at all. That's why they say not to use them. Maybe when you get to the transformation flow and get a Spark runtime there, that's when this gets better. That's what they anyway. Okay, so it's going to take a while, but we can also take another example in the syntax check. and then apply that in the new transformation, and then we can end this topic. The last example that we have, yeah, you can apply the lambda function and create a new column as the result of two columns and put it into a new column. Let's do a new column to create this one, and then we can open for questions after. So we will be coming back here and then just checking refresh. It's still, see, such a long time is because it's not good at all. Okay, it doesn't look like. It's still processing. Interesting. I didn't expect such a long time. Okay, something, it's coming back. So okay, as finished, which is good. Now refresh. It's finished. Actually, we can go and check to the details of this particular script, and then see that it's containing the right data set for this one. Okay, let me go and see the output of this particular local table, and it should have anything that is greater than 1,000 as the value in that. It's pretty slow. So again, okay, this has been the data flow. It still shows as completed, but I don't know why it is. It's just the status takes some time. Go to the monitor again to see. It's still running. Okay. Not sure, but this is finished at 9:58. Let me go and check the object. The log shows it's completed, so it must be there and loaded into the target table. Just that it's glitched that the status is not updated. My table is called LT and DataFlow Python. I'm going to put this into the data preview. Unfortunately, I don't have a SQL window. So to run a SQL query and apply the filters, I have to come to the data preview and then come to the bottom and apply filters here. Its value, it's always greater than 1,000. You don't see anything below 1,000 here, right? That's the lowest I can actually do sort ascending. So the lowest value is 1,031 cents. Anything below is not coming as because of the filter. So which means it's applying the filter. So now we're going to do one last example in the same data flow, adding a new column so that you are changing the structure of the column by creating a calculated column. So I'm going to put this in the data Python script, and here I will change this to script, change it, and then one filter applied on the same data frame. I'm going to call as a data frame, create a new column. This time I'm going to say I would call this as profit, a simple column, and then say I'm going to call this as df. Yeah, there's no code completion, nothing. You will have to be on your own value, and then I will apply 10%, which is going to be 0.1. I can put 0.1, but it's going to complain saying that 0.1 is a decimal thing, right? So I will need something called decimal notation in order to keep the value. So something like that. Otherwise, it's Python coding syntax. So if I'm using decimal, then I have to keep that inside the decimal thing. So we switch back to the data flow and then say, or instead of doing this whole thing, I would call just 10. Otherwise, if you are not doing a number, a floating point thing, then you have to put the decimal conversion. So I'm not doing it, just putting 10. So now the objective is that profit is being added. So let's see. So as soon as I added the profit, would it come to this new table? Or I'm going to remove this one. Come on. And then if I drag to the template table, would it be coming? Because I still see 3 columns, just because it has to be added explicitly because you're creating it in the Python script. So you're going to come back to this one and then add it. Okay, add column. It's not coming from the source, so there's nothing here. Then you'll have to explicitly say create a new column and then call it as what is that I have given? Profit. So that it matches. So my value data type, I have to exactly give the same data type of value. Think value is decimal and save it. Looks like that is the right one. If not, I have to change it appropriately so that it will get better. So save it. Now you will be able. Okay, that's fine. I don't want to save it. I will come back to the details and then remove this one and then create a new template. Now this time it's going to have 4 tables. Four rows, 4 columns. And it's just going to have table, local table, df, frame or something. Now it has created deploy table. And then now the new column is being calculated as part of the script inside, and then that column populated to the 4th column to this data set. So we can run this one and then observe that the profit is being calculated. Just a simple thing that you can apply functions, lambda functions, and you can apply all the data transformations that you can really see as part of these exercises that Google provided using pandas, intersect indexes, reshape. There are a lot of exercises here. No, not only these ones, there are many more. Okay, so with that, now the objective, what I wanted to tell you is that I wanted to give you how can you get started with the basic scripting of Python in local machine as well as a collaborative environment like this one, or you can even use Ripple as well, but this is easy. And you can use your GPT tools or LLM tools, generative AI tools to practice wherever you need it, corrections and suggestions, and then once you have the data structure and everything corrected for your transformation tested here, you copy that code and then take that code and put it into the script of transformation flow, not the data flow, because I don't think you will be doing any data flow development in future in the transformational flow, so that and they purposefully the scripting is only currently it is Python script. If you wanted SQL in transformational flow, here in data flow there is no SQL, but in transformational flow you do have SQL transformation and graphical view transform, both transforms there, and script option is also given for Python processing. Currently NumPy and pandas are there. You can leverage those pandas library for data frame processing, and lastly, we didn't touch PySpark here, but the PySpark, what really you're going to do, you're not going to do all these Python libraries. You're going to import PySpark which is almost like you're a SQL. You run a SQL command, and then a PySpark is wise enough to run that in the Python runtime environment with the help of Spark inside the Spark clusters. That we will be learning as part of Databricks exercises, where Databricks notebooks can have PySpark and Spark, Python and SQL together. General practice is you don't mix the cells with one Python cell and one other one SQL cell. So you always do a best practice as one, because some environments, platforms like pipelines of Databricks cannot support mixing of Python SQL in one notebook. Okay. So anyway, that's totally different. So with that all said, it's all up to you how much you wanted to expand your knowledge in data engineering and data science using Python, using notebooks. Okay, so I'm going to stop it here. Any questions? Just let me know. Okay.
Srikanth,
Yeah.
if I use SQL, even in PySpark also, I'll be using SQL. So what is the main advantage, Srikanth? I mean, are we running this in another Python environment? What advantage I get if I use PySpark instead of normal SQL?
No, you in the run you can mix and match. PySpark is one library, just the one library. It's not limited, right? You can use hundreds, thousands of other libraries as well, like pandas.
Okay.
It's a Python basically. You're writing SQL in Python. So PySpark is just just a module that allows you to write SQL inside the Python.
Oh, okay. So you mean to say I still can use all the libraries that
Yeah,
are
yeah, yeah.
associated? Okay.
In the Python, you can mix and match. For some functionalities use PySpark, and some functionalities use regular Python in the same program, in the same notebook. Because there are there is no such thing called PySpark as the language. It's Python. So
Python.
you create a Python notebook, and some you import PySpark, and some you import pandas, and use data frames as well as SQL both together. Yeah, and PySpark is the interface where you are writing on your Python script or SQL on a Spark compute. If you're going to write a SQL on regular database platform, which is totally relational, the database platform, it becomes database platform. But your PySpark, you're writing on Spark compute. Spark is really the key thing here. That's design. So PySpark is designed for writing writing SQL in Spark
Okay.
using Python as a Python module. That's why it's called PySpark. It doesn't mean that you can't write the Python in Spark, but it's a SQL code written in Python for Spark. That's what PySpark is all about.
Oh, thank
Yeah. Okay. So we leave this topic. I thought I would give the way to do this, starting with exercises, so that it can be a foundation for further data engineering things that going to happen as part of BDC in Snowflake and Fabric or in Databricks. Every other platform that you're going to work will have data notebooks as the uh, you can put these notebooks in the pipeline as well. So which means you put a proper scripts and then attach to the pipeline, so that data loaded according to the script that are part of your notebooks. So it's really in SAP. We understand, we don't use them, and it doesn't seem to be any plan to introduce these notebooks in HANA side at all, even in the other side of data lake also. But if you're using any other platform other than SAP, DataSphere Core HANA, then it is likely that you will be leveraging these programming notebooks as the main choice, your choice for pipelines. Okay, so understanding notebooks is so important in the data pipeline engineering. Okay, so I'm going to stop it here. We'll stop recording it.